The question says that they're giving you two vectors and they tell you where the points end. So if you can't read the chart, right, it's not that bad. This one ends at 4, 7, and this one over here ends at 5, 3. Okay? And we've already jumped to the easy way to do it. Okay? Not that it's really easier than anything else, but it's just something we're more comfortable with. If we call this vector A and we call this vector B, then what we're saying is vector A is equal to 5 vector i's. Remember what vector I is? Right, it's the unit vector on the x-axis, plus 3 vector j's. And vector B is 4 vector i's plus 7 vector j's. This is what it means to find the components of a vector and to write the vector in its component form. Now, from algebra, we know we can add the two equations. And we could say vector A plus vector B is equal to 9i, 9i plus 10j. And what does that mean? That means 9 i's brings us over here, and 10 j's brings us up here. This is where the new vector is going to end. And there's our new vector, A plus B, right? And it's the one that they refer to as the resultant vector. Okay. Now, let's go back for a minute and look at the instructions. It said, what did it say to do? It said translate one of the two vectors. Do you remember the definition of adding vectors from the book? Here. The sum of the two vectors is the vector from the beginning of the first one to the end of the second one if you take the tail of the second one and place it at the head of the first one. Here is your vector B, right? And here is your vector A. Translate means to slide, just to change its position without changing its direction. So how do we do that? Well, we could put the tail of this, right, at the head of the other one. And if we do that, we've added the two vectors. Try to remember, this is not something that's disconnected to reality. Remember, the whole thing about this is what happens when you put the two forces together, right? What happens if I walk this way and then I walk that way? Where do I wind up, right? Well, you wind up over here. Oh, so if I were headed this way and there was a wind that was pushing this way, in those particular magnitudes, it would wind up like that. And by the way, what did I do? I did it differently, didn't I? I took the head of A, the tail of A, and put it at the head of B. Or am I allowed to do that? The instructions said no. It said head of, but hey, look, does it make any difference? No, not really. This is the definition. This is sort of an algebraic way to do it. So it's like the other stuff we were doing too. There are two ways to think about this, or two different modalities, if you will. Okay. One of them is the geometric, right? The picture. Oh, I'm really good with drawings and moving things. That's what I like. I like the kinesthetic, right? Yada yada da. No, not me. I like the numbers. Just tell me what the numbers are. I'll add them up. Either way, no problem. Okay, same thing. Okay, that's what this is. Then when it says calculate the length of the resulting vector, and then it says, oh, did we get the length of the resulting vector? How am I going to get that length? What am I going to use? Pythagorean theorem. Wouldn't that apply only to a right triangle? Do I have a right triangle here? Right. It's here and here. I heard some other people using something else. What else were you going to use? No? Oh, okay, I thought I did. Okay, so yeah, in order to get the length, I go from here to here. What did the length of this, or the magnitude of the sum of the two of them, turn out to be? A squared plus b squared equals c squared, so you got to take the square root of it, right? So this turned out to be the square root of 181, is that what you said? Okay, and then you used a calculator to get an approximation of that, and it was 13.45. Okay, cool. All right, so now that's the answer to the first one. Now when it says you got a triangle, hey, what's that mean? I do have a triangle. Now, what was that? Okay, so now this is a law of cosines problem. Calculate the measure of the largest angle, right? That's this one. You should be able to do that.
No, it says angle that it makes with the x-axis.
Is that what it says?
Yeah.
No.
It says.
Oh, here it says that makes with the x-axis. Okay, right. Okay, so there are two of them, right? It says find the angle it makes with the x-axis, right? That's sort of, I think that's what they're calling the direction angle. And then this thing down here says you got the 2 with the vector forming a triangle, calculate the measure of the largest angle. That's this one. And at that point, you could use the law of sines or the law of cosines. Yeah.
I thought what it was asking for the third one is that you're supposed to connect the ending points of all 3 of your vectors and then find the largest angle of that triangle.
Nope. Because what it says is calculate the, right here it says calculate the length of the resultant vector. Which one is that? No, I understand. But which one is that? The resultant vector. Okay. So then it says the 2 given vectors and the resultant vector form a triangle. Okay? So they're not talking about the points at the end, here, here, and here. They're actually referring to the process of using the definition as opposed to the components, adding the components together. Using the definition of this. Okay, so then that would be this one here?
Yeah.
Okay. Okay, just to make sure that we're all on the same page. Okay. This was the angle for number 2, right? About 48 degrees, is that what you got? Great. And then if you go over here, okay. This is the chapter 10 page overview, and that's where we are at the moment. And there's a whole bunch of things here that you're going to learn how to do. So when we're all done, you probably want to go back here and make sure you can do them. But in the meantime, here's 10.1, and it says given 2 vectors, find the resultant vector by adding or subtracting them. We just did that, right? Okay, fine. And we did it 2 different ways. We did it by translating, and we did it by using the components. Okay. 10-2. Okay. So now, what are they asking us to do? Given the components of a 2-dimensional position vector, find its length, a unit vector in its direction, a scalar multiple of it, and its direction angle. I think they're calling the angle off the x-axis the direction angle. Okay, so that's what they're calling the direction angle. What's a unit vector? You remember I said you have to always figure out, with any question in math, you have to start with, do I know what the words mean? What are the definitions? Guess what? Right here on the next page, they give you all the definitions. so that position vector, displacement vector, magnitude, opposite unit vector, there we go. Right, what is it? It's a vector that's 1 unit long. Oh, that's, okay, great, right? Okay, vectors I and j are unit vectors in the x and y directions. A unit vector u in the direction of a given vector is found by dividing the vector by its length. Did we figure out how long this is from here to here? Well, let's get the exact answer. What was it? Okay, so the distance from here to here is the square root of 181, right? That's the distance, right? And this vector here is, what did we say it was? We said it was 9i plus 10j. So what's the unit vector along this direction? Well, here's the thing. This whole thing is this long, right? So if I chopped it up into these many pieces, each piece would be 1 unit long, right? So if I had whatever number this is, if I took this and chopped it into exactly that many pieces, each piece would be 1 unit long. Okay, so let's do that. That would be the unit vector, wouldn't it?